In this example, we're going to concern ourselves with calculating the specific gravity. Let's suppose that a certain bottle has a mass of 35 grams when empty and 98.44 grams when filled with water. Now let's suppose when filled with another fluid, the total mass of the fluid and the bottle is 90 grams. So what is the specific gravity of the other fluid compared to the density of water, assuming that the density of water is 1,000 kilograms per meter cubed? So let's begin by first using our density equation to calculate what the volume capacity of the bottle is. In other words, what volume of fluid can our bottle hold? To calculate the volume, we're going to use the mass of the water inside the bottle and the density of water. So we simply take this equation and rearrange and solve for volume. And we see that volume is equal to the mass of the water in the container in our bottle divided by the density of water. So we know what the density is. It's 1,000 kilograms per meter cubed, and that means to find the mass, we simply take the difference of these two quantities and divide that by 1,000 to convert our grams to kilograms. So 98.44 grams minus 35 grams gives us the amount in grams of water found inside our container. And if we take that difference and divide it by 1,000, that will give us the mass in kilograms. So take this mass in kilograms and divide it by the density of water, and we get approximately 6.34 times 10 to the negative 5 meters cubed is the volume that the bottle can hold. Now, in the second step, we actually want to use this information to calculate the specific gravity of our object. In other words, we want to find the ratio of the density of the fluid to the density of water. So the density of the fluid to the density of water, well, we know what this quantity is, but this quantity is simply the mass of that second fluid divided by the volume that the bottle can hold. So we know what the volume that the bottle can hold. That was found in part 1. And to find the mass, we simply take 90 grams, subtract 35 grams, the mass of the bottle, and that will give us the mass of the other fluid. And to convert from grams to kilograms, we simply take the difference, divide that by 1,000, and that gives us the mass in kilograms. So the mass in kilograms divided by the volume that the bottle can hold, given in part A as this quantity, and then divide that whole value by the density of water, 1,000 kilograms per meter cubed. And we get approximately a specific gravity of 0.87. So notice that this quantity is unitless because this is a ratio. We have the same units divided by the same units, so the units cancel. So this basically means that our water is more dense than the second fluid that we're using.